Hey everyone, welcome back to the AI Engineering for Flutter Developer series. In video 1, by the way, the video 1 is not out at the recording time of this second video, but that's why I haven't got your feedback yet. But in this video in the video 1, we'll cover the mindshare shift and build our first basic AI features. But here's the truth, most tutorial won't tell you. Building a basic AI feature is very easy, but building a reliable one that works well in production is completely different skill, and that's what we are actually trying to tackle. That is how we can launch a reliable AI feature in Flutter. So today we are going to focus on 3 crucial skills every AI engineer needs to know. The first being structured output, then to streaming and proper error handling. So structured output, focus on streaming as well, and how to handle error gracefully with Flutter when it comes to AI engineering. So by the end of this video, you know how to build AI features that are cleaner, more predictable, and much more production ready for production grade Flutter application. And without further ado, let's dive straight in. So we'll just touch on some key agendas and why some things matter. So part of it being that why free text AI responses are dangerous. That is, when we prompt AI, it generates a raw text for us. So why free text AI responses are dangerous to our production grade Flutter application. The second point being that how to force structured type responses using Gemini. So how we can force, when we are consuming endpoints, we receive JSON data that are forced to a particular structure. So with AI as well, we can force the structure for a particular response. And the third point is how to implement streaming for better user experience. And the fourth, how to undo failure gracefully. The major point is how to proper error handling, even in AI engineering for Flutter dev. So these are the major things that separate people who just use AI from real engineers. So the concepts that I just mentioned. So that's pretty much it. So we'll be starting with structured output first. So when we talk about structured output, when you ask an AI model a question, by default it gives you free text, that is a raw data that you just read through. That's flexible, but it's also messy and hard to work with in real application. Comparing it to real world scenario, that is when we listening to endpoints, we fetch data in JSON format and all. So structured output allows to force the model to return clean, predictable data, usually in JSON format, as we are aware of. So I will show you how to work through it and go through different aspects of it later in the course of this video. So the first thing we'll do is we define a schema. We'll make a request that return structured data. We pass it safely into that model. We just pass the response into a DAT model, and we will be good to go. So just to start, so first off, we'll go through again. Go through all the code. I've tried it out before actually recording this video, so I'll just go through the file, walk through all the concept and overview the decision behind it, so we can better understand the flow. So now we'll look at the article blueprint, this file. So this article blueprint, this is like the model that we have created for the response that we'll be getting from the AI model. I'll still show you how the prompt was actually structured for it to actually return it in this strongly typed modular response from Gemini. So the first thing is title, overview, difficulty, basically beginner, intermediate, and advanced. So estimated reading minutes, tags, key concepts, implementation steps, and if there's any code snippet as well. You can see that the tags, key concept, and implementation step are listed because they are like a bunch of lists. So basically this is just a model. I believe if you're not new to Flutter, at least you should have integrated endpoint before. So for every endpoint we create a model for it, basically to safely pass the JSON format into a DAT model essentially. So with the title and every other necessary information, and here we specify that the title is important, I mean, is mandatory. So if the title is null or is empty, then missing mandatory title file the structural output response. So we can return this in case the AI response did not actually give a title, because this example now is just like an article format that we are trying to fetch from Gemini, essentially. So these are our return types. So basically all the formats that we're getting: title, overview, difficulty, estimated running time, tags, key concept, implementation steps, code snippet, and so on. So that's pretty much on the article model, essentially. So the next thing now is the integration itself. So resilient AI service, that's where it is integrated. So inside this service now, we just have, if you watch the first video, by the time you watch the first video now, you understand the flow. So we have done this in the first video already. So the API key, which will submit, because you have to give your Gemini API key for you to use Gemini or Google AI Studio models, essentially. So we are using Gemini 3.1 Flash. Again, this is the model here. So this is the model we are using, Gemini 3.1 Flash Lite. So now inside the Gemini, that's why we integrate structured streaming and the error handling gracefully. So now we are using this package, which is Google AI Dat. So Google AI Dat to actually integrate Gemini, and if you wanted to use it for any other Google product like Vertex or Nano Banana whatsoever, you can as well use the package as well. So now when it comes to generated structure blueprints, now first off, we just do a check. This is the prompt. Basically we are fetching the prompt, and as well we have a retry function. So I will get to that when we get to error handling, because there's a retry function that was created in the error handling. So we just check if the API key exists and check if the prompt as well as 90. So after that, now we create a retry EPA. So now this retry basically depends if it fails. If it fails, fine. I mean, if it fails, it will retry. If not, it will just move through the action. So this retry EPA essentially acts exponential backoff, and exponential backoff is the concept in software engineering. Basically, that is a smart error handling strategy in computer network, basically an AWS, for gracefully handling errors. That is, when an error fails, it will create like an exponential time before the next retry, basically. So if you set like 1 second to actually try a particular action, if it fails, then it will increase the exponential time or difference within the next retry. So that's pretty much it's what we are doing inside this retry function. So this is the retry EPA as well. This is where we actually declare the action. So you can see the max attempt we set is 0. By default, it can be the increase from the API, from the call to action. Then the initial delay is 1. So by the time it's retrying again, it will increase the exponential time. So as you can see, the first is 1 second. So by the time it retries again, it will increment and so on and so forth till we reach our max attempt. So that's the error handling. So now inside the action, now basically just integrate our Google AI client. We provide the API key, then we create a structured prompt. So again, if you check through the article blueprint, we have already created the structure here as well to actually listen it, because we want it to actually flow with the model that we have created, which has to do with title, overview, difficulties, and other information that are listed there. So now inside the resilient AI service, now you can see that we specifically mentioned that your technical content architecture, generate a structured JSON blueprint for technical article, essentially. So technical article or feature guide. So straight JSON schema requirements, return only valid JSON objects with the following models. So you can see the title, the overview, the difficulty. So we already specify all the key names that we're expecting from the AI model, so it will be structured. So that is why we call this a structured output, essentially. So we structure the output that we're expecting, so we can actually pass it inside our DAT model that we have created. So that's pretty much it. on the structured output. So we specify it, then topic to generate. So from the prompt the user will type, so we just pass the topic. Basically, then after that, now we make a response. We make a request. So this is the generate content. And if you study the that package, which is Google AI, that there's generate content, there's stream content as well. There are two different functions. So now if you say, how do I generate text with Gemini? So if you show this example, so you see client.models.generate content. So we'll pass the model. This model uses 3.5. In this example, we use 3.1 flash essentially. So you can see then the request, the content that you want to generate, and any other thing you want to pass. So we just used the content and the part, which is test part, the system point, which is everything that we have here. So the row, so this row basically has the user row and the model row. If you hover it, you're going to see so producer, content, user, or model. So basically user row. So pretty much, so once we send the request and we send the prompt to the AI model, now we can now extract the generated text payload, because now the AI model is going to return it in JSON formats. Now it's essentially like we're actually integrating API essentially. So that's pretty much what we're doing. So but with this, we're actually telling, because we are just in communication with an AI model, so we are telling the AI model what we need, so we can fetch it, extract it, and decentralize it in a proper DAT model. So that's what is being done here. So now once we extract the generated text payload, now we check for any errors or whatsoever, if it's good to go. So this is safety flag. Now there's some prompt that some user might type that is security, what's it called now, that the AI model will not actually respond to, that will flag as security breach or whatsoever. So now with Gemini, now we can actually scan it, we can get a response like that, and with proper error handling, we can aggressively show an exemption to the user instead of just having a blank string or whatsoever. So now that's what we are doing here. So if finish response does safety, or the finish reason is equal to safety, then the request topic was flagged by Gemini safety filter. So that's this error handling in case there was any flag essentially. So outside that, then we fetch the response, then we pass it into raw data, raw text, so we can pass it to our model that we have here, which is article blueprint. So pretty much then we check the raw text as well, if the the response is empty or not. If it's empty, then we'll throw an exemption as well. So all this exemption has been built inside the exemption file. So I'm going to show that as well soon enough. So the exemption file. So that's how this works. So once the raw text is not empty, then we'll move to cleaning the markdown blocks and pass the JSON. So there's a function down below that cleans the markdown. Basically just remove all the special characters from the text and just convert it to a raw text that is readable. Then we can use JSON decode to just map the JSON file, the JSON data to our DAT model essentially. Then we just return article blueprints from JSON. Then we pass the JSON map and also the raw text to our blueprint model. The article blueprint model. So that's pretty much everything we are doing for the structured output. So the first thing again is the major thing is we inform the AI how we want our response to be structured. So after informing the AI, basically we initiate most definitely, and we build a structured JSON prompt enforcing strict schema. So after that, now we get the data. We do some validation to check if there was any error or whatsoever before actually converting it to JSON format. So before actually decentralizing it into like strongly typed DAT model. So after everything checks out fine, then we just clean the markdown and deserialize it into that model essentially. So pretty much what structured output is all about. So some of the teaching points now in structured output has to do with like free text responses can break your UI when key names changes or JSON formatting varies. If you have been building mobile application for a while with Flutter and you have been integrating API, one of the issues that comes with building mobile apps, especially when you're not the backend dev, is that when key changes, when key name changes in API response, it distorts the whole application. That is, the model does not expect what the value is, or even if the data type is something different from what has been set in the code base, then it breaks the UI essentially. So, but with this clean markdown and the way we have handled this gracefully, we're able to clean that. So no matter what, the AI features and all the formatting we have done here, we still handle everything gracefully. The second point essentially is enforcing structured output schema to ensure clean data and matching clean data matching your that model essentially. So this is pretty much it. That is, we enforce a structured output schema. So this essentially to match whatsoever that we have set inside our model. So if you are building something, you create a model, basically just run through the flow of what you need, all the points that you need, so you can build your UI accordingly. So by the time you are done with that, when you are prompting, when you are creating the prompt, you can strictly instruct the AI model to return it in this kind of format based on what you need essentially. So the third point will be we safely handle this decentralization with fallback in this article blueprint. So basically we just handle this gracefully. So added article blueprint from JSON, which is this. So which is this essentially. So we just handle everything. So we check everything accordingly to actually listen to the key names and also to receive the value essentially. So inside the structured output as well, we have some exemption, and inside this AI exemption, we already declare all the exemption. It consists of the message, status code, can retry, and as well when we get to proper error handling, we'll touch the can retry, because there's some exemption that the user should not be able to retry should not be able to retry unless they actually now fix what the error is or change the prompt whatsoever. So that's pretty much on error handling. So the next thing now is streaming. So now, one thing is users don't like staring at a loading spinner while waiting for long AI response. Streaming lets the text appear gradually, which feel much more natural and responsive. So basically that's what streaming is all about. So we set up a streaming request and the partial response, update the UI smoothly as token arrives, and just show the UI show the user the screen responsively. So that's pretty much what streaming is all about. And if you go through the package as well, you can see this is how to generate text with Gemini. The next is how to stream Gemini output rather. So if you show the example, you see streaming uses the same response type as normal generation, so you can switch between buffered and increment output without changing the rest of your app code. So essentially this just show like a progress. So instead of the loading spinner, it shows like the AI module is actually writing the response and stuff like that, so they can see as it progresses. That's essentially what the streaming is all about. So the streaming it's just different from the generate. You can see the generate that we only just cause client model, the model to generate content, and that's pretty much. But in streaming, you have to wait for it and use we have to loop through it, so to generate what we want. So stream generate content as well, and pretty much what we are doing with streaming. So now let's go to our streaming code base here. So we have streaming output widget here. So the first thing as well is the model. So the model, inside the model now we have this text buffer is streaming just to probably present like the loading spinner for the button if it's streaming or not. So I mean the other pointer that shows if the AI model is still writing or not. So we have the chunk count to count the chunk, also the elapsed duration, and uncancelled stream. So this uncancelled stream, one thing to note as well when it comes to streaming, because we have to cancel any subscription in order to avoid memory leakage and also consuming too much user, because by the time the user comes back to the app, it will not be nice, especially on some devices. So that's pretty much on this. So we have all this model. Then inside our code base itself, I will still show the UI anyways. Oh, by the way, let me just display the UI so we can let me refresh as well. So as I was saying, so basically this is you can see the three: structured, streaming, and resilience, basically failure resilience. So this is streaming part. So this is just the UI part of things. So with the streaming now, we can check, we can tell the user probably receiving token live with just like tweaking the UI, so it can start the action by the time the streaming starts. So if it's streaming, then the user can cancel the stream as well, like before the user, the AI model actually finishes the response as well. So that's pretty much this chunk received. It will count all the chunk counted and the duration as well, then basically the other information. So if the buffer is empty, which is this card that we have here, so there's the output. Then if it's not empty, then we receive. You can see in this streaming now, I will still go through the function essentially, but now we are receiving a raw data in markdown format. So this is the one that actually show like a typing indicator kind of stuff. So that's pretty much on the streaming output widget. So now let's go through the integration. So let me collapse the structured output so we can go through the streaming part of things. So this is the streaming content now. So streaming content, we are going to use something different. So we use the incremental text token as they arrive from Gemini in real time. So we actually like show this the response in real time as it arrives from Gemini. So starting with the integration as well, providing the API key, then we use the stream generate content instead of generate content function that we use for structured output. So after we create this, then we use the await, the await for loop, just like it was used there as well. So we just specify the stream outside, so it can just be used inside the for loop. So now after we have created the stream generates content function, now inside the await, basically we fetch any response that is coming in real time from Gemini. We are just fetching everything and we are showing it real time to the user inside this box. So essentially, so we check through and we get the part. Well, once the part is fine, then we are able to just yield the token, basically to yield the response. So in this stream, we are not actually formatting everything. We are just showing the raw markdown essentially. So you see the test by the time I'm actually testing the output out. So that's that for streaming. So streaming. So some of the point as well that you might have not, or let me just state it, is staring at a loading spinner for 5 seconds feels slow, but with streaming token it reduces like passive latency to under 300 milliseconds or thereabout. So that's one of the points. And another crucial engineering skill is for every stream inside our the output where we're actually showing everything now. For every stream now, so for every stream, this is stream subscription. So always store your stream subscription so you can cancel. You can call cancel rather if the user navigates away from the screen or something like that. So always like store your stream subscription essentially. So that's another crucial engineering skill that we must pay attention to. So that's why we create the subscription, stream subscription, so we can cancel it inside this post. So by the time the user move the way, we can just cancel the stream essentially to avoid any memory leakage as well. So that's pretty much on streaming output as well. So now let's go through error handling and resilience. So by the time we are done with error handling, then we can now go through we can test how the application actually works and how it feels. So now error handling is like what most tutorials or developers skip. So a lot of developer or a lot of tutorial don't actually talk more on error handling when it comes to AI model, and we know that AI can fail for many reasons. So errors it's one of the reasons many AI feature break in production. Trying to integrate AI into a production level application, and if the errors, it's unlike endpoint that we can actually manage ourselves. AI model is not like that. It's based on the instruction that we give it. So if the instruction delivers fine, then we are good. Otherwise, if it does not deliver, the error differs. And if it's normal backend now, we can attest to all the errors that will come from it, probably bad inputs or bad submission and all sorts of network. But with AI, there are different there are many other reasons that the AI can fail, and one of it has to do with network issues, rate limits, invalid responses, timeout, or model refusing the request. So that's like 4 or 5 points I just mentioned that reasons why AI can fail. So a proper error handling system includes clear error types, retry logic, meaningful feedback to the user, and fallback behavior. So we'll go through all the exemption now inside the exemption file. So now you can see inside the exemption we have this abstract for the AI exemption, so it can be used everywhere we are actually calling the AI. So throughout this services, now we use the exemption that we have created, so it can actually pass it. So let me close this so we can go through the failure. Although we stimulate some failure, so we can just try it out. It's just like a stimulation essentially. So now the exemption, now we create network exemption, basically network issue. So this is thrown when there's network connection or circuit timeout error occurs. So that's for network. Then rate limits, rate limits. So when you hit rate limits with AI model, schema passing AI exemption, basically when the structured output fails to deserialize into that model, probably one key name is missing or whatsoever, you can throw a proper error, an exemption to the user as well. Safety revision exemption, so throw when model refers to prompt due to safety or policy filter. So that's that. Then invalid API key exemption, if there's no API key given or if it's invalid as well. Then any other error, we just throw it and just pass a message. And another thing is we filter between, you can see now that inside the model we have can retry. So there's some exemption that we shouldn't be able to retry. Part of it is this safety refusal. So let's say user type a prompt that has security issues with that the AI model will filter out, then the user should not be able to retry that. You can see that the retry has been set to false. So the user should not be able to retry until the user restructure the prompt or whatsoever. And as well, invalid API key, that simply means that the API key does not exist. So until the user set the API key before, it can as well retry the prompt over again. So one of it is we create a robust AI service layer. So the service layer, we create a robust service layer. We handle different failure cases inside the exemption, and we showed good error states in the user in the presentation part of things inside this our app now. So we show like a good error state to the user. So another teaching point, I mentioned teaching points for the 2 points I already mentioned, which stems from structured output and as well streaming as well. So structured output, streaming now for error handling and resilience. So now we group errors into like actionable types. For example, just like we mentioned here, all the actionable types include network, rate limits, schema passing, and safety refusal exemption. Then the second point being that distinguish between retrievable errors, just like I mentioned earlier, and unretrievable errors. For example, invalid API key and safety refusal. And the third point being that show user-friendly error state UI via the error resilience. So just build your own exemption model to catch any error, and in case some errors that you might not be aware of in the future, probably there's an update, then you can just throw a message to the user instead of just leaving the user clueless. So now we'll put everything together and we are going to display how it works. So basically everything has been grouped together inside this our part 2 application now. So I will refresh the app now. Let me refresh the app. Let me get the API key. So I'll just head over to my Google AI Studio, copy my API key, and come back to the app. Let me set it here. So I'm just paste, save the API key. So for the structured, so by default, I already set a prompt, which is build a real-time chat application, chat app with Flutter and Firebase. So if you click on generate structured outputs now, so click on it, you see it will take a while. So it's generated in JSON format. So now if you actually fetch the raw data, it will be in JSON format. So with that, we're able to like structure our UI. So we're able to, it's just like when we're actually fetching response from an endpoint, essentially, we structure our UI based on what we are expecting from the backend, essentially. So that's essentially what we're doing here. So we have this difficulty, the timestamp, and also the title, the overview, the tags, key concepts, implementation steps, and code snippet as well. You can see everything is structured. So this is structured output. So when it comes to streaming, okay, let me go to streaming. So now you see when I start streaming, so let's start streaming. So you can see the streaming has started and it's actually created a timer. By the time it's done already, the timer has already ended. So this is streaming essentially. So this is the markdown format for all the streaming response. So it generates everything and give us all the output that is needed for streaming. So pretty much, and for solid error handling or resilience, as we may call it. So this is just like a we just set it boilerplate essentially, so we can see how all the errors are handling. So this here now has 5 or 6 errors that we mentioned here. Number 1, which is rate limit, network timeout, invalidation schema, simulate safety refusal, and text Gemini, read Gemini API request if there's no API key. So now for the rate limits, now if you trigger it, this will be the output that will be shown to the user. Like, here's too many requests, Gemini rate limit reach. So for the other parts, network timeout, basically socket exemption, JSON, invalid JSON schema, then we can show the user a missing mandatory title key in JSON, safety refusal as well, content policy refusal, and test key as well. So that's pretty much on all the architectural and decision. Why is this taking time? Probably there's an error or something. Okay, there's no error. So let me just retry again and let me refresh. Okay, probably because I already, but anyways, let me retry again. Okay, yeah. So invalid or missing Gemini API key. So all these are just set by default, just test how the error handling works essentially. So that's pretty much on this building real AI feature in a production Flutter application. But just to do a quick takeaways or quick recap on what we have studied or we have covered so far. So the first point being that always prefer structured output when you need predictable data. So again, okay, I already cancelled it. Yeah, so but anytime you need a predictable data, create a structured output to for the AI, so you can actually determine, you can know what you are expecting from the AI model. So that's the first point. And second point will be use streaming to improve passive performance. So to communicate with streaming as well, we can use this structured output as well, so we can show the user, but that we have to do with a lot of work, because we have to show probably markdown preview or design it as its flows as well. And the third point is treat error handling as a first thought or first class citizen, essentially. Like, AI can fail for many reasons, and one of the things is network correctly means API key missing, and safety refusal, and several other things. So create exemption that actually undoes any error that the AI might throw. So these three things will immediately raise the quality of any AI feature you build in your Flutter app. So that's pretty much on everything I have in this part 2 of this series. So if you haven't already downloaded the free engineering starter pack, I created a starter pack here. So just head over to techwithsam.dev/AI starter kit. So I have updated it with code and patterns from these particular videos. So it's still the same pack in video 1, although for this video 2 now you get the updated version. So in the next video now we are going to go into deeper AI agents and workflows where things start getting really powerful. And that will be all for this video. And if this helped you, please like the video, leave a comment, and subscribe to the channel. I did love to know which of these 3 techniques you find most useful, that is structured output, streaming, or error handling. So let me know in the comment below. Thank you again for watching, and I will see you in video 3. Take care for now. Peace.